Hello, today I thought we would talk about the tourmaline family. As you can see in front of us, we have a whole bunch of different tourmalines from all over the world. So Chompy and I are going to be explaining the tourmaline family to us. And like all mineral families, tourmaline is a big family of minerals, and it encompasses more than one mineral species. Now, a lot of people think that it's based on color, and it really is not based on color. The gem names are based on color. You get Rubellite, which is a mineral, but it's usually pink. You can get Elbaite, which is usually green, but sometimes it can be pink. And so you can't really use the colors to identify the mineral species. There's just no way of doing that, because almost every color that tourmaline comes in each species. There's a few that tend to always be the same color, but it tends to be, not is always the same color. So I'm going to go over the mineral names with you. Rubellite, like this one, is almost always pink. And so many tourmalines also form in what's called a solid solution, where you get more than one mineral species in the same crystal. And you can see that when you look at minerals like this. You can see that it's green on the top and pink on the bottom. So you actually have Elbaite and Rubellite in the same crystal. So some of the other names that, the gem names that the tourmalines come in is Acorite, which is colorless. And yes, tourmaline does come colorless, and you can see that occasionally. And usually you just see it in sections on tourmalines. You'll get a crystal, a long crystal, and it'll just be a section in it that's colorless. Or you'll get a slice like this, where you get a cross section, and you can see there's some colorless sections around the edges. So. Chrome tourmaline tends to be emerald green, and it's due to a high chrome content in it, just like a lot of minerals that are green are chrome. And then cuprian is caused by copper, and I don't have a good example of that because it's fairly rare, and so I just don't have a good sample of that to show. Parariba is another blue tourmaline, and it's more of an aquamarine / topaz, blue topaz colored tourmaline. Famous from the Parariba mine in Brazil. And again, I don't have a really good sample to show of that one. Canary tourmaline is just like you would think, canary yellow. And Indicolite is blue. And let's see, I had some Indicolites here. Here is one. If you get the edge of the color, you can see there's some blue in there, some blue-green. And so that would be Indicolite. Rubellite is almost always pink, but it doesn't have to be. It can be green, and it can be yellow and a little bit orangey. Verdite, verd means green, and so like verdite jade, the tourmaline that is about that color, jade green, would be the verd green, verdilite. Manganese, the MN version of tourmaline, doesn't really have a gem name. They just call it MN tourmaline. And it comes in this cinnamon color. I don't know if you can see that very well in the light there. And then Schorl. Schorl is always black tourmaline. And again, it doesn't. If you cut it thin enough, it's not usually black. Apparently there's no real black tourmaline. It just appears black because it's so dark green. And if you cut it in thin sections, really thin sections, you can see often it's a solid solution of other minerals as well. Other tourmalines as well in there, and so that's kind of cool. And then you get things like watermelon tourmaline. Watermelon tourmalines are fun. They have the watermelon pink on the inside and the green rind on the outside, and these can get rather large. They can get up to 4 or 5 inches across, but this is the most common size. They're famous from Brazil, where the majority of them come from. These ones are also called watermelon tourmalines, even though it's blue on the outside and not green. Kind of a misnomer. And some people will call a watermelon tourmaline when you have the length of the crystal is where you have the length of the crystal, some of it's pink and some of it's green. This isn't a true watermelon tourmaline. This is just a tourmaline crystal that happens to be pink and green. The watermelons have to have the pink rind, the pink centers with the green rind. Brazil is famous for the tourmaline. In fact, it's probably the most famous place in the world for tourmaline. There's a number of large tourmaline deposits down there. Some of them cover many miles. We got to go down and collect down there in June, and we just had a blast down there, being lowered down on little straps into the bottom of these mines, some of them hundreds of feet deep. And was it scary? Yes, it was kind of scary. Was it fun? Oh, it was certainly fun. We'd do it again in a heartbeat. I want to go. But yeah, we're going to go again. I'll take you with me. Okay. So other places in the world that you get tourmalines, Pakistan, Nigeria, Afghanistan, of course, Vietnam, China, Russia, all produce large quantities of beautiful tourmalines. In the United States, specifically the two coasts, Maine has some great tourmaline mines. California obviously has some large tourmaline mines. Some of the largest tourmaline crystals in the world have come from San Diego, and very famous for those. They're beautiful. Here in Utah, we get great tourmalines. I'm going to show you this one here. This is about as good as it gets. It's black tourmaline, and I have smashed these down and looked at them under the microscope, and they do tend to be very, very dark green to almost opaque black. But that's as good as a tourmaline gets here in Utah. So tourmalines form in pegmatites, and pegmatites a pegmatite is defined as a coarse-grained igneous rock inside of a finer-grained igneous rock. Imagine looking for a gas bubble inside of a ball of magma granite, and you find this ball. Sometimes they're completely filled in with large crystals. Sometimes they get cavities, and inside those cavities is where you get freestanding crystals, and you can get tourmalines up to, well, in Brazil, some of them have been up to 3 feet tall, so they can get very large. Usually not that large. You know, that's a good-sized tourmaline from San Diego. You know, they got some that were this big, and so they can get very large. You can see this is a slice of one, and you can see that's the cross section of a crystal. So it was long. It was a good-sized crystal, Coke can size, and so. They can get in there. Now, tourmaline is often referred to as the trash mineral of a pegmatite because it's the very last thing that forms. Once all the other minerals, the quartz and topaz or feldspar, any of those other minerals that are forming in there, once they're done forming, then the tourmalines can form it. So it's often considered a trash mineral. And if you look at the chemical composition, it's like it's made up of everything. Everything just got dumped into the end. And it's because as these pegmatites are forming and developing, the tourmalines are made up of the last stuff. And so you get some really interesting colors from that as well. So anyway, that's why it's often referred to as the trash mineral. So inside those pegmatites, you can get some very acidic water in there that will etch away the green tourmaline, leaving just the pink. And these are scepters. So the green came all the way down. It's etched. The groundwater has etched it away, leaving just the pink, because it can do that because the pink and the green are made up of two different chemical compositions, and so what's making up the green is being dissolved away. And you can get some really funky formations. Here's one, beautiful terminations across the top with the pink underneath, all etched, very neat. Here's one where it shows the contact. This crystal was attached like that. You can tell from the water levels in here where the groundwater was sitting. It was sitting just like that. And so that's been etched out of the center. Now, when you look at one of these, you're like, why did it not etch the rest of this down here? And so there's become a couple of other theories that have popped up about why it would do that. And one of them is that instead of being dissolved, or dissolution theory, there's obstruction theory, which means there was something else here that the tourmaline grew through that did not allow everything to develop into a normal crystal, a normal freestanding crystal, say something like that. And so you can have maybe a layer of another mineral possibly that was there that the pink grew through, and then the green grew around the rest of it, and that other mineral's gone now. It could have been something like calcite. That's very common for scepters to form like that in quartz, and because they get trapped in something that's growing along with it. So it is often usually calcite. So. All right, if you have any questions, put them in the comments below. Thanks for watching. Thanks, we really enjoyed your company. And we'll talk to you later.